Limits of trig functions. That's today and tomorrow. Tomorrow is going to be work period. We've plotted for you the graphs of sine theta, cos theta, and tan theta. Okay, and what we want to do is examine the graphs and state the following limits. Okay, so just looking at the graph, we'll leave up here. What's the limit as theta approaches 0 of sine theta? 0. How about cos theta? 1. How about tan theta? 0. How about pi over 2 for sine theta? 1. Pi over 2 for cos theta? 0. And pi over 2 for tan theta? Does not exist. Does not exist. Right, because we have two different limits, right? One-sided limits. Use the above, the limits above and properties of limits. So this is just to get us thinking properties of limits, right? So what's cosecant defined as?
1 over sine.
1 over sine theta. Now the limit of a quotient is the quotient of the limit, so it's the limit as theta approaches 0 of 1, and the limit as theta approaches 0 of sine theta, and that will come out to 1 over 0. All right. Now, since the limit of sine theta, limit as theta approaches 0 of sine theta, so we need to look at the left and right-sided limits. So the limit as theta approaches 0 from above or from the right of 1 over sine theta is positive infinity, right? We're going to a very small positive value. And the limit as theta approaches 0 from below, or negative of 1 over sine theta, is negative infinity. So the limit of cosecant theta does not exist. Okay, now what's next? B. Oh, these are stacked, and yours are beside. Secant. What's secant? 1 over cos theta. Okay, again, the limit of a quotient is the quotient of the limit, so this is cos. Limit as theta approaches this is 1, and limit as theta approaches 0 of cos theta is 1, which is equal to, and the limit is 1. Yeah. We won. C, cotan. What's cotan? Cos theta over sine theta. Okay, limit of a quotient is the quotient of the limit, so it's the limit of cos theta over sine theta, which is limit as theta approaches 0 of cos theta is 1. Limit as theta approaches 0 of sine theta is. Okay, since the limit of sine theta, we need to look at the left and the right-sided limits. So as we're approaching from above, okay, we're going to have 1 over, now sine theta is going to be small, but positive, right? So what's 1 over a very small positive number? Positive infinity. Approaching from below, still going to be 1 over a very small negative number, which is negative infinity. And so the limit of theta approaching 0 of cotan theta is, does not exist. Okay, you try this one. This time as theta approaches pi over 2. Okay, so how's that? Yes? High fives going on, so must be good. Right. 3. Okay. You do these. Okay. I'm gonna pause this. Give you like 10 minutes. Okay, I was gonna show the answers for a few seconds. If you are watching the video, you could pause at this point to check your answers, or you could check them with the PDF. Okay, so moving on. So 2 very special limits for angles measured in radians. We actually covered these the other day, right? We went through them, but so the first one, the value of this is 1, right? We looked at that. We went into decimals. We looked at it. Proof is beyond the scope of this course, so it is on page 303. And you want to take one of those handouts there? Just be a little less long. We did this one as well, right? And we found that this limit was 0. So let's run through the proof, because we can actually prove this. So what can we do, right? Well, we've got this cos theta minus 1. So one of the things we know is let's rationalize, in a sense rationalize, not really, right? Let's multiply by cos theta plus 1 over cos theta plus 1. So that's going to give us cos squared theta minus 1 over theta times cos theta plus 1. Now, what's another word for cos squared theta minus 1? Well, not word, but what's, okay, almost negative sine squared, right? Okay, so remember, sine squared plus cos squared is 1, so it's going to be negative sine squared theta over theta times cos theta plus 1. And now, here's a trick that we're going to use a lot. I've got negative sine squared theta, so I can write that as sine theta times negative sine theta. And these guys on the bottom we can split out, right? Because it's a product of 2 things. So we're going to write sine theta over theta. Why would we want to do that? Because we know that limit, right? So we know the limit of sine theta over theta. It's written at the top of the page, actually on your formula sheet, right? And then what are we left with? Well, we've got this negative sine theta, so over cos theta plus 1. So the limit of a product is the product of the limits. And here we've got negative sine theta. So sine theta, limit of as theta approaches 0 of sine theta is 1, right? Written right up there. And negative sine theta, so what's this going to work out to? You can actually evaluate this, and what do you get? Yeah. So as theta approaches 0, the numerator is 0, denominator is 2, right? It's 1 plus 1. And 1 times 0 over 2 is 0. Okay, so that little in summary. In summary, okay, so you've got those 2, right? They're on the formula sheet. I gave you a pink formula sheet. If you don't have one, get one from me. And there are 2 that you're given, right? So what we're going to aim to do in a lot of these is say, can we get this? Right? Is there some way to manipulate what we have to get this or get this? Right? And if we can get either of those expressions, we say, aha, so we know what those limits are, and probably what's left we'll actually evaluate. All right, part C, examples. 150 examples. No, it's only like 20 of them, I think. Now, one thing, right? I mean, math as it's presented to you is always presented as a fait accompli, right? I mean, it's just, yeah, look, it all nicely flows. Math as it's actually done tends to not necessarily flow as nicely. It tends to be a series of stops and starts and wrong things and get out the eraser and erase that, right? So just keep that in mind. Okay, when you're doing it, oh, it's not flowing like, you know, you showed me the examples, or yeah, that's just the way it works, right? So when I went through these, last night or the night before or something. It actually took a while, right? It took over an hour, hour and a half to go through these. Okay. Now you've got, I mean, the homework is like 7 to 38 and 48 and whatever, right? And we'll have all day tomorrow to work on that. We may actually even finish this today. We'll probably end up finishing early after. So, oh, we're going to use voice. But if I'm going too fast, you got to let me know. Okay. So if there's something up there that you want further explanation of, it's up to you to say, hang on, wait, where did that come from? Why are we doing that particular thing? Okay, and there's more than one way to, you know, skin the proverbial cat. So there's more than one way to do these often, right? Not that we're skinning any, that was grade 11 biology. All right, so the limit as theta approaches 0 of theta over sine theta. What could that be based on the thing we have in a box? It's got to be 1, right? It's just the reciprocal of, so like, is it going to evaluate differently? No. It's just going to evaluate exactly the same, right? So that's just a 1. Limit as theta approaches 0 of 1 minus cos theta over theta. Okay, what do you think we're going to do with this? Multiply it by 1 plus cos theta over 1 plus cos theta. So, I don't want to show, I don't want to, well, I'm not going to run out of room, I guess, unless I write really big, so. Okay, so. Okay, so combine those, what do we get? What do we get up top? 1 minus cos squared theta, right? So we're setting it up as a difference of squares, right? We're getting 1 minus cos squared theta over theta times 1 plus cos theta. It's like darn near the proof we just did, right? Like very similar. What's 1 minus cos squared? Sine squared theta. Okay, what are we going to do with this? We've got a product, right? We can write that as factors. One of the factors can be sine theta over theta, right? Whose limit we know. Okay. So we can write this as, so sine theta over theta times sine theta over 1 plus cos theta. Okay, we've got the limit of a product, and I'm going to have to squeeze over here to do that. Well, I can just kick up here and there's space. So we got sine theta over theta times limit as theta approaches 0 of sine theta over 1 plus cos theta so limit of blah blah sine theta over theta is 1, and what's the limit as theta approaches 0 of sine theta over 1 plus cos theta? 0 over 2. 1 times 0 over 2 is 0.
Wouldn't you just take a negative out of the top, and then you'd have negative cos minus 1, cos of theta minus 1 over theta, which is equal to 0, and then you've got the 0?
Oh, that's too easy.
But,
You're right, yeah.
Okay.
See, there's more than one way to skin a cat. All right, so let's do that. We'll squeeze that illustrious thing in here. So you could write limit. Yeah. Some of us aren't that smart. So cos theta minus 1 over theta, which is the negative limit of is just 0. Yeah, that's a whole lot smarter. But you know, if we didn't know that other limit, again, this is how we could do it from scratch, right? He said he was trying to save himself, but it is scratch. Okay, next one. So we've got this, right? So what are we going to do? Okay, Peter, what are we going to do?
You're
Yes.
gonna factor out 1/2, and then you'll have sine of x over x times 1/2.
So limit x approaches 0 of 1/2 times sine x over x. Yeah, which is, so the half just comes out. Remember that this is a pretty basic concept of limits. When we have I'm not actually going to do this detail in future, we'll just take the half and stick it in front. So what we're going to do is take the half and stick it in front. Right, so the limit of a constant times a function is the constant times the limit of the function. Okay, so in future when we start pulling constants out, we're really just going to do that. Sine x over x, which is the half of what? Or just 1/2. Okay, so in future we'll just kind of go here, right? I'm doing that so you can see, well, okay, it's a product, and then you know, I could do the limit of the constant times the limit of this, but the limit of the constant is just the constant. Okay, everybody good? Leave that for a second. Yeah, now we're going to finish early and all that talk. Stop me if you need to see, or you want to make a suggestion, right? Like, hey, it'd be a lot easier to do. Limit as theta approaches 0 of the sine of 6 theta over 3 theta. Any ideas? And the 3 theta, well, it's the sine of 6 theta. It's not a 6 theta, right? It's the sine of 6, so you can't cancel it. Okay, so here's what we're going to do. This is, again, another trick. Not trick. I mean, it's a method. This is a method. It's not a trick. It's a method. So we're going to write the limit as theta approaches 0 of the sine of 6 theta over 6 theta. Huh? Because we know what that limit is. What is that? 1, right? It's like the limit of x over x is 1. And then you know, hang on a sec. You change that. You're right, I did, right? So let's multiply that by 6 theta. Yeah, that's exactly the same as all of that, except we still got that 3 theta to deal with, right? So this is this, right? This is just sine of 6 theta. We've got to divide it by 3 theta. Well, make our lives a little bit easier. Let's just multiply by 1 over 3 theta. So are those two statements equivalent? Yeah, because if you cross off the 6 thetas, you're left with sine 6 theta over 3 theta, right? If you just cross these two guys off, you got this over this. Yeah.
Can you just do sine of 6 theta over 6 theta times 2?
Well, it's going to be that, but we have to cancel this.
It's easier if you just take a 2 out from the bottom.
Take a 2 out from the bottom. What? How do you take a 2 out from the bottom?
If you multiply, if you write 6 theta on the bottom and then just add another bracket times 2, then it's the same thing.
Sure. I just like this because it actually shows more detail, I guess. Right? You're not always going to have a 3 theta on the bottom, and then it's like, how do you handle it? So, now, here's what we're also going to do. We're going to make one more change. And that is, we're going to say that, where are we going to say this? We're going to say, as theta approaches 0, what can we say about 6 theta? which is 0. So we're going to say, hey, I'm dealing with 6 thetas now, right? I'm not dealing with thetas or x's or whatever. And we're going to change this guy here to be the limit as 6, don't say that fast. Say 6 theta, 6 times back. So the limit as 6 theta approaches 0 of this, right? Which is now going to give us the fact that that's 1. Okay, the 3 theta and the 6 theta leave you with the 2. The 2 is going to come out front, right? So 2 is a constant, so it's 2 times the limit as 6 theta approaches 0 of sine 6 theta over 6 theta, okay, which is 2 times 1, which is 2.
So do you need to show that work for like as theta approaches 0, 6 theta approaches 0 every time we do this question?
No, just replace the theta with a 6 theta.
Okay.
Okay. So that's cool. So yeah, anytime you see like whatever. So in the next one, right, we see 2 theta. Although, hang on, now you might have a 3 in there. Change the 3 to a 2.
Son of a gun.
And there's a reason why, right? Because I asked why, and they said, well, because you can do this next one. So you can do the next one exactly as we did this one, right? Just take the sine 2 theta over theta, blah, blah, blah. But you can also say, well, but sine 2 theta is equal to 2 sine theta cos theta. So we could use a trig identity, right? So we can do this very similarly to how we do this, or we can rewrite this as the limit as theta approaches 0 of 2 sine theta cos theta over theta. Okay, what are we going to do with that? Well, okay, 2 things, right? So number 1, we can move the 2 out front, right? So we're going to move the 2 out front. So it's 2 times the limit as theta approaches 0. Now I'm not going to rewrite sine theta cos theta over theta. What am I going to write? Yeah, change the 3 to a 2, he said. I will rewind the tape for you if you like, but it's in there. Okay? And the reason we did that one, if it was a 3 theta, it would really, you just do it this way and the 3 and boom, boom, boom. It's exactly the same and it doesn't do anything for you. But with the 2, then we can say, well, wait, this could be written as 2 sine theta cos theta. Okay, we'll take the 2 out front. I got sine theta over theta times cos theta over 1, right? So split that because we know that limit, right? So that's 2 times limit, let's throw brackets around that, right? Because we're doing product, so limit theta approaches 0 of sine theta over theta times the limit as theta approaches 0 of cos theta, which is 2 times, so what's this limit? Sine theta over theta. 1. And what's the limit as theta approaches 0 of cos theta? 1. And so the ultimate answer is 2. Okay, any questions? So it's just a different way of handling it, that, right? You could have written the limit of sine theta, sine 2 theta over 2 theta times 2 theta times 1 over theta. You know, it would look a lot like D. Cross off the thetas, move the 2 in front, and boom, done. Okay, same answer. Okay. And again, your choice, right? Nobody's going to say, do this by using trig identities. But it could be. Okay, x squared minus 3 sine x over x. What are we going to do with that? You can't really factor an x, right? I mean, it's a sine x, it's not an x in the sense of, you know, this isn't 3x sine x. So here, let's do this. The limit as x approaches 0, so let's break this into factors. Let's go x squared over x. Well, actually, sorry, we're not really breaking it into factors. It's a sum or a difference, right? The common denominator is an x, so the line before that may have looked like this. Okay, so we're splitting out. You know, it's like if you had 7x minus 4 over 3, you could write that as 7x over 3 minus 4 over 3, right? And just normally what we would do, normally we'd start with this and combine it to get this, right? Now we're just breaking it out. So the common denominator is x, and it's x squared minus 3 sine x, and both are over x. Okay, this is nice, right? It's just going to be an x. This, we know how to do that, right? Okay, so limit as x approaches 0 of x minus. So I'm going to do the difference of limits is the limit of a difference is the difference of the limits. Okay, the limit. Okay, so what are we going to do, right? Well, we're going to go to 3x approaches 0. Oh, sorry, no, we're not. It's just x. Minus the limit of x approaches 0. Actually, you know what? Let's pull the 3 out too. So minus 3 times the limit as x approaches 0 of sine x over x. Okay, so what's the limit as x approaches 0 of x? 0. Minus 3 times, what's the limit as x approaches 0 of sine x over x? Well, yeah, and then, yeah. Okay, redeem yourself. The final answer is negative 3. There you go. There's a lot of pressure there. Okay. Yeah, make sense? Everything's good? Yeah.
Don't you multiply the negative 3 by 0? Maybe not subtract.
So we took the expression, which was this expression. We rewrote it as a difference of two fractions, right? So we split it up. The limit of a difference is the difference of the individual limits, right? It's on your limit property thing in whatever page in the book. Okay, so this again, it's just using properties of limits, right? So we now have the limit as x approaches 0 of x, which is 0, minus, we pulled the 3 out, because it's a constant, right? And it's 3 times limit of x approaches 0 of sine x over x, right? And remember, that's what we're aiming for, right? We're aiming for sine x over x, right? And we're aiming for cos theta minus 1 over theta. Okay? If we can get one of those, we know what its limit is, right? 1 for sine x over x, and we can say, oh, look, I can get a sine x over x, right? Pull the 3 out front. So it's 0 minus 3 times, and the limit of x approaches 0 of sine x over x is 1. 0 minus 3 is negative 3. Okay? All right. Next one, where are we? Limit as x approaches pi. There's actually a few ways we can tackle this, right? So one way, we'll do a couple of ways, I guess. So one way is to say, let t equal x minus pi. Okay. So we got that x minus pi in the denominator, right? We're just going to let something stand in for it. Then what's x going to equal in this case? So x will equal t plus pi. Okay. And what's going to happen as x approaches pi, what's going to happen to t?
T would approach 0.
Yeah, t is going to approach 0, right? Okay, so that's the preliminary work. So we're going to say the limit as t approaches 0, right? As x approaches pi, t approaches 0, so we're just replacing there. Of sine of x, but x is now t plus pi. So the sine of t plus pi over, and what's x minus pi? T. Thus the limit as t approaches 0. Now there's a identity for that. Sine of t plus pi is negative sine t over t. And what's the limit as t approaches 0 of negative sine t over t? Negative 1, right? So do we need to show, we don't need to write the negative of the limit as t approaches 0 of sine t over t. We'll just go with negative 1. Okay, so that's one option. Actually, well, really, that's the best option. Yeah, you just do that. That's the best way. I think the book might show something about I don't know what the book shows. They show a slightly different way, right? But it's basically the same idea. Okay, so basically, that's a strategy you want to adopt when you're seeing something like this, right? Instead of x approaching 0, you're seeing x approaches pi, and you want to be able to kind of rewrite that, so you've got a limit as it approaches 0. Why? Well, because if you can get this guy out of it, we know that limit, right? Like, you know what? I'm just going to fill in. All right, 2 cos x minus 2 over 6x. What can we do? I can factor, yeah.
Sorry, can you go back to the question?
Sure.
So how do you get from sine t plus pi to get a negative sine t over t?
There's an identity.
Oh.
There's an identity. I don't know, is it on your sheet?
Yeah, it's there.
It is sort of, you could use the sum and difference identity for that, right? Because you're gonna end up with a sine pi, and the sine of pi is 0. You're gonna end up with cos pi, and cos pi is like negative 1, so it's gonna ultimately flip down to that. Okay. There are more comprehensive identity sheets which actually list those, right? Because t plus pi is really just a rotation, right? Pi degrees. So you're going to have the same sign, but it's going to be in a different quadrant. So it's going to be negative. It's a quadrant 1, it'll end up in 3. Same value, but negative. Quadrant 2, it'll end up in 4. Same value, but negative, right? So it's a rotational identity, but the sum and difference identity will work too. Okay. So what was the suggestion? We can factor this time, right? Okay, so 2 actually is a common factor, right? It's not like the 2's somewhere else on the back side of the page. Right? What is this one? H? No. Front and bottom. All right, so now what?
Take the 2 to the outside.
Yeah, well, let's take the 2 6 to a third and throw that out front.
Sure.
Okay? Does that make sense? So if the next thing I write is this, well, not if. The next thing I'm writing is this, but does it make sense? Okay, so you know where the 1/3 came from, right? So we got the 2 and the 6. You could cancel it in place here if you wanted. You could just do stuff like this, 1 and 3. Okay, and it's constant, right? So we're just going to start putting constants out front. We're not going to worry about saying it's a constant times this and then move the constant out. Doesn't make sense. What's the limit as x approaches 0 of cos x minus 1 over x? 0. So what's the answer? It's a third of 0, which is 0. Okay. Are we going too fast? No? You sure?
If we go faster.
Probably, you know. I had the big setup and we'll go into Y's time. We're going to be finished like early, so I'm just feel I'm going too fast. All right, limit as theta approaches 0 of theta cosecant theta. So what's another way to say that?
Theta over sine of theta.
Theta over sine of theta. Okay, now what?
It's 1.
Yeah, it's the reciprocal of sine theta over theta, right? Yeah.
For question H, why did the 2x's appear? Like, why is it just x after you take out the 1/3?
What 2x? I see no 2x.
Like, it starts with 6x in the bottom, right? You
Yes.
take out a 1/3. Wouldn't that be?
Okay, so we took a 2 out of the top, right? 2 is a common factor at the top.
So you take the 2 out from there, and the 2
Cancels
factors
into the
with
6.
that, so that's 1 over 3 is the coefficient, and that's the
Oh.
1/3 we're taking out.
Okay, yeah, gotcha.
Gotcha. Okay.
Yeah.
Anybody else? Delayed reactions? Want to see G or A again or something? No. Sorry.
Actually, I
It's
have
okay.
a question from yesterday.
We can ask that later. All right. So what is this?
It was Sunday.
It's 1, right? Just the reciprocal of sine theta over theta, right? And the limit as theta approaches 0 of sine theta over theta is 1. Okay. What's next? J. Limit as x approaches 0 of sine 7x over sine 4x. So, we're going to adopt the same strategy as we did before, right? When you have the sine of something times x. So it's the limit. I might have to write small here. Okay, so we're going to go the limit of sine 7x over 7x times 7x, right? Which we all agree is just the same as sine 7x. Okay? Over, so what are we going to do on the bottom? Sine 4x over 4x times okay, we good? Yeah? Okay. So let's take these guys out. Got a constant, right? Let's just pull it out front. 7 over 4. Okay? What's the final answer? Just 7 over 4, right? 'Cause what are we left with? Well, we got the limit of sine 7x over 7x, and we got the limit of sine 4x over sine 4x. Okay. Which is, yeah, 1 over 1, and it's just going to be 7 quarters. But, you know, we got to show this, right? So, let's do this. So it's the limit of a quotient. Let's do it as the quotient of the limits. And up top, I'm going to do the limit as 7x approaches 0. And underneath, what are we going to do? Limit as 4x approaches 0. Wait. Okay, again, pause for understanding. So, any questions on so far? So when you see a sine 7x, 8x, 9x, 117x, you just want to put it over that same thing, right? Because we know that the limit of the sine of something, over the same thing, is equal to 1. Okay. Now, we have to make an adjustment. You can't just write sine 7x over 7x. You can't just leave that, because you would change the question totally. So we multiply by 7x. Okay, and then we did the same thing with the denominator, and had the 4x. We crossed off the x's, canceled the x's on the 7x and 4x. 7 over 4 is a constant. We pulled that out front. So it's 7 over 4 times 1 over 1. Okay, and we know, again, I don't think you need to write this. As x approaches 0, 7x approaches 0, 4x approaches 0. Yep.
Why do we have to deal with that? Can we just take out 7/4 in the first step and be done with it?
Ultimately, that's the answer, but you actually have to show that,
But you're showing it. Like, if you take out 7/4, that's 1.
No, you gotta go through the steps. 10 of 6. Everybody good with J? Once, twice, thrice. K, limit as theta approaches 0, tan of 6 theta over 3. What can we start by doing? Okay, but what can we start by doing? But what can we start by doing? Yeah, but what can we start by doing? What can we do with that 3?
You can factor out 1/3 and put it outside of the limit.
Yeah, let's just do 1/3 times the limit of tan theta over 6 theta, right? It eliminates the denominator, which is always a good thing. As theta approaches 0, what is tan 6 theta? What does it evaluate to? What's the tan of 0, he said, asking in a different way. Look to your thingy and tell me what the tan of 0 is.
It's 0.
0, okay. So, then what?
It's 1/3 of 0. Oh my god.
Boom, done. It's continuous, right? I mean, tan at 0 is continuous, so we just evaluate it. Sometimes they just evaluate, right? Or sometimes you can actually, I can just work this out. All right, limit as theta approaches 0 of the secant of theta minus 1 over theta. It's not sec squared, it's sec theta. All right. Luckily, there's lots of room below there, right? So, what are we going to do? Well, I'm going to go the limit as theta approaches 0. So, what's another word for secant? It's not a word. What's another expression for secant? 1 over cos. 1 over cos theta minus 1. Now, seeing as I've already got a fraction in there, I'm going to just throw the over theta out as a times 1 over theta. Okay, that way I want to have fractions over fractions and have to deal with all of that stuff. So we need this. So give me the, you're going to subtract that, right? So come up with an expression for 1 over cos theta minus 1 as something blah blah over something, right? So as a fraction, combine it, add the fraction.
1 minus cos theta over cos of theta.
Yeah, 1 minus cos theta over cos theta. And, here, let's just pull that theta and throw it down there. Okay, so we got 1 minus cos theta over theta cos theta. Now, what's our big thing? What do we got? We got cos theta minus 1 over theta. right? That limit, cos theta minus 1 over theta. We got 1 minus cos theta. Is there any difference between cos theta minus 1 and 1 minus cos theta? But not really, right? Not in terms of the limit. So there is, but so the limit cos theta minus 1 over theta. And I think we did this, right? Wasn't it one of the earlier ones? We did 1 minus cos theta. Which one was it? Yeah, B. Remember B? So we did B. So we know 1 minus cos theta over theta, right? And it's similar enough to the formula sheet that we should just be able to, say, oh yeah, that's also going to be 0. Okay, so then let's split it out. So the limit as theta approaches 0 of 1 minus cos theta over theta times 1 over cos theta. Which is the limit of a product, so it becomes the product of the limits Okay, so what's the first limit? 0. It doesn't really matter what the second one is, but the second limit is 1. Yeah, I know. So it's 0 times 1, which is 0. Okay, question. Half an hour. We only have half an hour. We have half an hour. Let's drag this out. They're pretty good. You're not just lying to me. Okay. Next. Well, you get a good start on the homework today, and then tomorrow, and then. Okay, 2 cos squared x minus 1. That's there's an identity for that, right? Look on the pink sheet. What's 2 cos squared theta minus 1? Or do they use x? What's 2 cos squared x minus 1? What is it? Cos 2x. Okay? Alright. So, let's use that. So we have the limit as x approaches 0 of cos 2x over cos x. Whoops. Don't get excited and try and cancel the coses and the x's. Oh, it must just be 2. Okay, what's cos 0? What's cos 2 times 0? What's the answer? Yeah, so this limit exists here, right? I mean, there's no 0 down here, is it? So it's 1 over 1, which is 1. All right, you could have just done that up here too, right? You could have just thrown a 0 in there and gone 2 times 1 is 1 minus 1 is, sorry, 2 times 1 is 2 minus 1 is 1 over 1. Didn't need no fancy trig identity. N. Sine 2x over, so what's sine 2x? 2 sine x cos x. So the limit 2 sine x cos x over x cos x. Okay, what would we do with the 2?
Take it to the outside.
Yeah, let's take the 2 out front, right? It's constant, let's get rid of it, right? It's not going to cancel with anything else. So it's 2 times the limit as x approaches 0. Okay, let's get creative. How are we going to write this? Okay, it's a product, right? We're going to write it as the product of 2 factors. The first factor is sine of x over x, right? And the second factor is? Well, it's kind of gone anyway, isn't it? Okay, what's the answer? So remember what we're aiming for, right? If we can express, if we get an expression of sine x over x, or we get an expression of cos theta minus 1 over theta, or 1 minus cos theta over theta, or x over sine x, right? That's kind of, keep that in mind. The end game, right? It's like playing chess. You look ahead a few moves. Can I write this so that? Okay, and when you look at this, you say, oh, yeah, okay, boom, done, right? All right, 3 more. Why did he even mention this? Could take a long time. I don't get it.
Boost or something and it didn't take as long.
Yeah, I guess, eh? You guys are, I mean, I walked down to see where the other class was, like after an hour, and then at the end of class, and after an hour, I think they were on like J, yeah, they were like on J. 1 minus cos cubed is a difference of cubes. So it means you can factor it. So factor it. You need some practice factoring a difference of cubes. Just remember the first one is just 1 minus cos theta, right? And I never know how to do this, so. Now, one. Plus cos squared minus cos squared. Plus cos theta minus cos theta. Okay, does it work? I factor these by the seat of my pants, really, right? If it's a plus, then I know the first factor is the cube root plus the cube root, and if it's a minus, I know the factor is cube root minus cube root, and then I just kind of wing it from there. You can memorize them, right? I mean, but I can't remember. What's another word for sine? Not another word. What's another way to express sine squared?
1 minus cos squared of theta.
Yeah, which might come in handy, right? Because everything else is cos theta, so we can get sine squared as 1 minus cos squared. And what can we do with 1 minus cos squared? Yeah, we could factor it, right? And, one of those factors is going to cancel with this guy, right? So we got 1 minus cos theta. 1 plus cos theta plus cos squared theta over 1 plus cos theta, 1 minus cos theta. Now, all of those things which may have evaluated to 0 no longer evaluate to 0, right? They're gone. So we can just plug in theta as 0 and evaluate this, right? So it's like 1 plus cos 0, not theta, plus cos squared 0 over 1 plus cos 0. So it's 1 plus 1 plus 1 over 1 plus 1. Do not cancel these. They're not factors. You can't just, if you do that, it's going to be wrong. You just have, it's just straight evaluate at this point, right? Plug in 0 for theta. No problems now. There's no dividing by 0. Okay. P. So we got one of these x approaches 3/2, right? And we got this x minus 3/2, so. Or sorry, 3 pi over 2, really. So we've already used t, we'll use u. Let u equal x minus 3 pi over 2. Then, what's x equal to? U plus 3 pi over 2, right? Yeah, move it over. And we could say, as x approaches 3 pi over 2, then what? U approaches 0. Okay, cool. So now we can go up here. So now instead of doing anything in terms of x, we're now doing it all in terms of u, right? So x approaches 3 pi over 2, well, that's the limit as u approaches 0. Cos of what? Plus, I think. Okay. So now we can't have x's in there, right? Can't do a limit with u's and x's mixed together. So x is u plus 3. That's why we write this out here, right? We can just look to do the substitution. So it's u plus 3 pi over 2 over u. And we have a cos A plus B situation, right? So, what's the cos of A plus B? I know not these. Okay. So that's the one that goes, yeah, it's cos minus sine sine. Okay, so cos u, cos 3 pi over 2 minus sine u, sine 3 pi over 2 over u, over u. So I just drew mu. Okay, well, one of those guys has to be a 0, right? I don't know. What's the cos of 3 pi over 2? That's 0. What's the sine of 3 pi over 2? I think it's negative 1. Okay, so this is 0, and this is negative 1. So cos u times 0, 0, minus negative sine u is positive sine u. And limit approaches, u approaches 0, sine u over u is 1. Who knew? Who knew this whole thing would just end up as the sine of something over the same thing? Questions? Comments? Concerns? Going too fast. Okay, what's his name? Oh, yes.
Why can't you just plug in 3 pi over 2 for x again?
No, I don't know. Could you? Because you'll end up with 0 on the bottom. That's why. And, it's worth a try, right? Obviously, before we go through all the machinations and find out that, oh, it's the tan of 6 theta and theta approach 0, and that goes 0. Or why did I do all this sine 6 theta over cos 6 theta? And I don't even know where we would go from there. Although, I guess cos 6 theta as it approaches 0 would be 1. The secant of 2x times the cos of sine of x. Wow. We're going to see a lot of stuff like this in the future, in the near future. Okay, so, well, it's a product, right? So it's sec 2x times the limit of cos of sine of x. Can we find the secant of 0?
Yeah,
What is it?
just one, isn't it?
Yeah, it is, isn't it? Right, because it's just 1 over the cos of 0. Yeah, okay, that's 1. What's, so it's the cos of sine 0. What's sine 0? Sine 0 is 0. What's cos 0? Oh, okay. Whew. Nothing fancy required in this one, right? So it all existed, right? I mean, the secant of 0 exists. The sine of 0 is 1. The cos of 1 is 1. And 1 times 1 is 1. Okay, so if we need to go... Honestly, when I did this sheet, it seemed harder.